So we learned some logarithm rules that allow us to calculate things that are products of things or quotients of things. And so I want you to look at what we were given for this problem. It says, given that the log of 2 is approximately 3/10, and that the log of 3 is approximately 48/100, the log of 7 is approximately 85/100, the natural log of 2 is approximately 69/100, the natural log of 3 is approximately 1.1, natural log of 5 is approximately 1.61, and the natural log of 7 is approximately 1.95. What they're doing is they're giving us problems that are asking us to use logarithm rules and the information we are given above to be able to approximate things without using a calculator. So let's look at problem number 1. It wants us to try and approximate the log of 21. Well, the log of 21 isn't in the list that they gave us up on top, but we want to see if we can rewrite 21 as a product of some of the numbers that they gave us. And we can. What we can do is we can rewrite the log of 21 as the log of 7 times 3. And we have the log of 7 written up here, and we have the log of 3 written right here. We have approximations for both of those. Applying our logarithm rules, if you have a product of logs with the same base, we can rewrite them as the sum of the log of 7 plus the log of 3. And since we have an approximation for the log of 7, it's 0.85, we can then add it to our approximation for the log of 3, which is 0.48. And so then without a calculator, you'd be able to combine those two together and make that 0.85 plus 0.48, which is 1.33. So there's our approximation for the log of 21. Now let's do it with the natural log of 10. So for natural log of 10, I want to try and rewrite that as the natural log of 2 of the numbers that we have up in our approximation. So natural log of 5 is on our list, and the natural log of 2 is on our list. So I can rewrite the natural log of 10 as the product of 5 times 2. So using our logarithm rule, this is the same thing as the natural log of 5 plus the natural log of 2. The approximation they gave us for the natural log of 5 is 1.61, and the approximation that they gave us for the natural log of 2 is 0.69. So we're going to combine those two together, 1.61 plus 0.69, and that's going to give us approximately 2.3. Number 3 has the log of 2/7, which definitely is not in our list. However, we can rewrite a quotient as a difference of logarithms with the same base. So the log of 2/7 is the same thing as the log of 2 minus the log of 7. We have an approximation for the log of 2 on our list. They gave us 0.3, and they gave us an approximation for the log of 7 as 0.85. So 0.3 minus 0.85 is going to give us negative 0.55. Now, number 4 looks like it's super tricky, but we need to remember that we have a way that we can rewrite the natural log of the cube root of 4/15. This is the same thing as the natural log of 4/15 raised to the 1/3 power. That's what it means to be a cube root of something. And then we had another rule that said that if you have a logarithm that is raised to an exponent, you can take that exponent and drop it down in front of the logarithm. So that 1/3 can come down in front of the natural log of 4/15. Okay, so the 1/3 is going to stay out front, and then 4/15 I can now rewrite as the natural log of 4 minus the natural log of 15. But again, when I look up at my list, I don't have a natural log of 4 and I don't have a natural log of 15, but I can rewrite both of those as things I do have natural logs of. I could rewrite this as 1/3 times the quantity, natural log of 2 times 2, minus the natural log of 3 times 5. Which can then be written as 1/3 times the natural log of 2 plus the natural log of 2 minus, and I need to be careful here and put parentheses, the natural log of 3 plus the natural log of 5. Each of those pieces now have their own approximation, so I can go ahead and put those in now. So I have 1/3 times our natural log of 2 approximation is 0.69 plus another 0.69 minus the natural log of 3, that's 1.1, minus, if I distribute that minus sign to both of those pieces inside parentheses, 1.61.